Okay, welcome. Today we're going to continue on with solving of quadratic equations. So go ahead and take your notes out, and remember that if you need to pause the video because you're falling behind, go ahead and do that because we want our notes to be complete. And also, if you didn't understand a concept, remember to stop the video, rewind it, and listen to it again. Okay, so let's take a look at one of the essential questions for this unit, and that is students will be able to solve quadratic equation using multiple techniques. At this point, we know one technique, that's solving by factoring. And it's a great method. It's the go-to move, as I call it. It's the choice method. But it's only applicable when the quadratic equation is factorable. If it's not factorable, we got to use another one of the techniques. So let's take a look at a technique. Our objective for the day is students will solve quadratic equations using the quadratic formula. So this is going to be our second technique. So our action will be to solve. What are we solving? Quadratic equations. And how are we going to do it this time? Quadratic formula. Okay, let's take a look at some vocabulary. Okay, the vocabulary word we need for the quadratic formula is a recall word, means we've seen it before, is standard form. A quadratic equation in standard form. A quadratic equation in the form of ax squared plus bx plus c is equal to 0. So we call this is our standard form. Remember, standard form has uh, all the terms on one side, all the terms on one side, and set equal to 0. It's also in descending order. If we look at the exponents, they descend down. This one starts at 2, this one's at 1, and this one we can say at 0. It's our constant. So 2, 1, 0. It's descending. So critical attribute for a quadratic equation to be in standard form is all the terms must be on one side, and we can say set equal to 0, and in descending order. Here are two examples. You can see the difference between the example and the non-example is the placement of the 6. This one's equal to 0, while this one's equal to 6. Okay, so this is not in standard form, while the example is in standard form. Okay, at this point, I'm going to have you pause the video in just a second and answer some questions on the form. When you're done answering the questions on the form, go ahead and start the video back up, and we'll move to applying the quadratic formula. So let's go ahead and do that right now, please. Okay, hopefully you have your form all completed and we're ready to move on. Okay, so here's our quadratic formula. Quadratic formula is not new. You learned it in Algebra 1. It goes like this. For ax squared plus bx plus c to equal 0, so it's saying if we're in standard form, the value of x is given by, and this is our formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a, where a, b, and c are our coefficients on the terms in our quadratic equation. So you can see how important standard form is. If you don't put it in standard, have these in descending order, you may mix up your a, b's, and c's, therefore placing them wrong in the formula and therefore giving the wrong answer. Okay, so make sure you start to memorize this if you don't have it memorized. It's going to be useful and you're going to need it quite a bit. Okay, let's move on to our first example. So let's go ahead and write it down. This is x squared plus 3x is equal to 2. And the first thing we want to use the quadratic formula is it needs to be in standard form. So step number 1 is to write in standard form. Standard form again is making it equal to 0 and all terms in descending order. So to make this equal to 0, we subtract 2 from both sides. This is x squared plus 3x minus 2. Remember, these aren't like terms, don't try to add them together. And that's equal to, those guys go away, 0. So step number 1 is to write in standard form, or set equal to 0. Step number 2, identify your a, b, and c. Okay, a, b, and c are the coefficients. So the coefficient on x squared is 1. Even though it's not there, it's understood to be 1. So there's your a, Your B is 3 because we are in descending order, so that's your B. And your C, don't forget to take the sign negatives, is -2. A is 1, B is 3, C is -2. So we wrote in standard form, we identified A, B, and C. Step 3 is the substitution. Now when we substitute, the easiest way not to make a mistake is to write down the formula first. That's what I'm going to do. -b plus or minus square root of b squared minus 4 times a times c, all divided by 2a. Okay, with a quick substitution, I've identified a, b, and c. They have actual values. Let's go ahead and plug them in. And what I like to do is simply rewrite the formula and leave parentheses. This is an indicator saying that I need to substitute in a value. So rewriting using parentheses all over 2a. There we go. And with a quick substitution, let's see. Opposite of b, b is 3. Plus or minus the square root of b squared, so that would be 3 again. Minus 4 times a, this times a is 1, times c, and c is -2. Let's see if I can get that in there. All divided by 2 times a, and a is 1. Quick substitution. Okay, so we wrote in standard form by setting equal to 0. We identified the a, b's, and c's, making sure we took any negatives. We did a substitution, so we just substituted in the a, b's, and c's into our formula. And our last step is simply simplify. And this is all arithmetic. Now, what we've noticed in the past, all the arithmetic errors, or the majority of them, seem to come from what's underneath the radical. Okay, so what I suggest is we do this part of the math first, because we just do a lot less errors if we do it first. That's what we're going to do. So we're going to look at 3 squared minus 4 times 1 times -2. Well, I know 3 squared is 9. -4 times 1 times -2 is +8, so it equals 17. Therefore, we can say the opposite of 3, or -3, so x is equal to -3, plus or minus the square root. Now all that expression simplifies to 17, all over 2 times 1. And here are our two answers to our quadratic formula. I'm sorry, to our quadratic equation using our quadratic formula. The steps were write in standard form, identify a, b, and c, substitute them in, and just simplify them. Okay, again, I'm going to have you pause the video and answer some set of questions that go with this example. When you're done with that, go ahead and restart the video and we'll move on. So go ahead and do that right now, please. Okay, let's take a look at example 2. Now this example, I'm going to have you do a little more steps and me less, but we'll compare our answers and see what we get. So here's our next example. 25x squared minus 18x is equal to 12x minus 9. Again, if you're falling behind, remember to pause the video and keep your notes complete. Now, as I look at this problem, I see I've got a lot of terms and I've got some bigger numbers. But don't be scared. Just go with what you know. And our first step is write in standard form. We got to set this equal to 0. Okay, so go ahead and try to set it equal to 0. Pause the video if necessary. Okay, to set it equal to 0, I'm simply going to subtract 12x from both sides. 12 minus 12 is 0. Negative 18x minus 12x is negative 30x. Then I also have to add 9. And there's no constant over there, so 9 minus 9 is 0. I'm simply going to tack on a 9 at the end. Now I'm in descending order, set equal to 0. I'm ready to identify a, b, and c. In this case, my a is 25. My b is negative 30, again, circle negative. And my c is +9. Step number 3, let's substitute. So go ahead and write your equation down and substitute in and see what you get. When you're done, go ahead and start the video back up because you're probably going to need to pause it, and we'll continue on. So go ahead and pause the video and do your substitution and turn the video back on. Okay, so remember that if you don't start writing down your formula, it's a good way to memorize it as you go. Negative b plus or minus b squared minus 4 times a times c all over 2 times a. Let's do our substitution. The opposite of b, that would be negative 30. So on yours, check and make sure you have the negative and negative 30. Plus or minus square root of b squared, that's negative 30 squared. 4 times a, which is 25, times c, which appears to be 9, all over 2 times a. And a, again, is 25. Okay, it looks like we have some big numbers, but that's okay. So let's go ahead and simplify what's underneath the radical first. So go ahead and pause the video, and let's simplify that first and see what we get. Go ahead and do that now. Okay, simplifying what's underneath the radical, that would be negative 30 squared minus 4 times 25 times 9. Now negative 30 squared, anytime a negative squared, it's positive, so that's going to be positive 900. Okay, 4 times 25, that's like 4 quarters, that's 100. 100 times 9 is 900, so it's going to be minus 900. 900 minus 900 is simply just 0. Okay, let's go ahead and rewrite this problem and finish our simplification. So the opposite of negative 30 is positive 30 plus or minus the square root of 0 all over 50. Okay, we know the square root of 0 is 0. So this is 30 plus 0 all over 50 and 30 minus 0 all over 50. So 30 plus or minus 0 is simply just 30. So this is 30 over 50, which reduces down to 3/5. Okay, so go ahead and pause the video. Make sure you've got these steps down. You understand the simplification, and when you're ready, let's move on to our last example. Okay, for the last example of negative x squared plus 4x is equal to 5, I would like you to go step by step and work this out. When you're done, I would like you to restart the video and we'll check it to my work. And if you miss anything, make the corrections there. And if you didn't get something, make sure you add it to your notes. So let's go ahead and let's see if you can do the steps. So pause the video now. When you're done, go ahead and turn it back on. Okay, hopefully you have an answer. You can see how to do this. So step number 1 says to put it equal to 0, put it in standard form. So I'm going to subtract 5 from both sides. That leaves me negative x squared plus 4x minus 5 is equal to 0. So we'll call this standard form, and I'll abbreviate it just like that. Next step is to identify your a, b, and c. So in this case, a is equal to negative 1. B is positive 4. C is negative 5. We're going to substitute them into the equation. So x is equal to negative b. Again, I'm writing it out because it helps me memorize it. So that's b squared minus 4 times a times c, all divided by 2a. So with a quick substitution, we get negative b, which is 4, plus or minus the square root of 4 squared minus 4 times a, which is negative 1. So we're just substituting in, times c, which is negative 5, all over 2 times negative 1. Okay, so remember again, I do this piece first. So 4 squared, plug in the computer, let it get caught back up. Start that one again. 4 squared minus 4 times negative 1, negative times negative 5. So order of operations, say exponent. A negative times a negative times a negative will be negative. 4 times 1 times 5 is 20. So this appears to be 16 minus 20, or negative 4. So that means we have negative 4 plus or minus the square root of negative 4, and 2 times negative 1 is all over negative 2. Okay, lastly, we need to simplify the square root of a negative 4. Well, we have to do a recall. Recall complex numbers or imaginary numbers. We know that I is equal to the square root of negative 1. So this can be simplified to negative 4. Now the square root of 4, let's put this over here, do some side work, equals the square root of negative 1 times the square root of 4, or I, and this guy is 2. So this becomes 2i. So the square root of 4 is 2, and we kick the I out. This is 2i, and this is all over negative 2. So take a second, and need to pause the video, and let's make sure it's down. Okay, we do have some more simplification. I notice that 2 goes into 4 and 2. So this can actually be reduced, and this is how we reduce. So make sure this makes your notes. Okay, what we're going to do is we're going to look for a common factor in the numerator that crosses out with something in the denominator. Now negative 4 and 2, I can pull out a negative 2. That leaves me a positive 2 there, plus or minus I. So I pulled out a negative 2, all over negative 2. Then we can say these two cross cancel, and I'm left with 2 plus or minus I, imaginary solution. So let's go ahead and pause the video and answer some questions on the form. When you're done, we'll restart the video and finish up. Okay, so hopefully between these these 3 examples, we can understand the concept on how to use the quadratic formula and be able to solve our quadratic equations. In the past, we've seen kids make the most mistakes in the simplification part. So the part we just took the notes on from here down seems to be an area of confusion. So what we're going to do in our last couple problems, they're quick, is just go over the simplification aspect on how do we simplify once we've plugged everything in and did the arithmetic. So let's go ahead and do 2 more. Okay, so in your notes, write 4 plus square root of 32 all divided by 4. Okay, so what we have here is a problem that looks similar to something we did with the quadratic formula that needs to be simplified. And our steps are pretty easy. The first thing we do is we look at the radical. Can we simplify the square root of 32? So no matter what the problem is, we always look, can I simplify the radical? Okay, the square root of 32 looks to be, let's see, that would be 4 times 8 and 4 times 4. So I can rewrite the square root of 32 to the square root of 4 times the square root of 4 times the square root of 2, or the square root of 4 times 2. So this actually becomes plus or minus the square root of 4. And remember, the properties say we can break this up, times the square root of 4 times the square root of 2, all over 4. Okay, so all we did is we took this, we took the square root of each piece. That's a property of radicals. And to simplify that, we know that is square root of 4 is 2, Square root of 4 is 2, so this is actually equal to 4 plus or minus 2 times 2 is 4 times the square root of 2, all divided by 4. So what we did is we square rooted the radical first. Okay, our second step is there a common factor? Is there a common factor between 4 and 4 square roots of 2 that also divides into a factor of 4? So I notice that 4 goes into both of these, so I'm going to factor out a 4. So here it is. I'm going to pull a 4 out of the front. In doing so, I'm left with a 1 plus or minus, factor out the 4. That would be 1. So 1 square roots of 2 all over 4. And now we can simply, a little lag in the computer, divide. We divide out the terms, so this would be 1 plus or minus the square root of 2. And that's how we simplify after we use the quadratic formula. Simplify the radical using a factor tree, and then see if we can divide out a common term. Okay, let's try one more. We have 4 plus or minus the square root of 72 all over 2. So again, let's do the radical. Square root of 72, that's 9 times 8. I like 9 because 9 is a perfect square. That's the square root of 9 is 3. So I'm going to stop right there. 8 is 4 times 2. Square root of 4 is 2. So I'm going to stop right there and say this is the square root of 9 times the square root of 4 times the square root of 2. Okay, I know this is 3 times square root of 4 is 2 times the square root of 2. 3 times 2 is 6, so this is 6 square roots of 2. So rewriting this, this is 4 plus or minus 6 square roots of 2 all over 2. Okay, if you need to, pause the video and look at the simplification. Because our second step is, can we factor? Is there a common factor that 4 and 6 have in common, or common factor, be 2? Well, looks like I can pull a 2 out. So if I pull a 2 out, I'm left with 2 plus or minus 3 square roots of 2 all over 2. And then lastly, we divide. Those go away, so my answer would be, in simplified form, 2 plus or minus, left my 3 out, 3 square roots of 2. Okay, go ahead and pause the video and fill out the form and get ready to do the homework assignment.